Hello everybody, my name is Harry. This is the first video I'm making for my Harry Talks Tech website on harrytalks.tech, where I'd like to be publishing a lot more content on everything surrounding software engineering. Today, presenting to you a solutions architecture document, or a SAD document. In real life, this would be much more detailed and cover every single aspect of your solution from end to end. Today, I'll be highlighting important sections for you. Please find timestamps of those important sections for your reference, with some examples of what could be important for your solution. And yeah, please enjoy and let's jump into it. Today I'll be presenting a make-believe company called Starship e-commerce platform and their SAD document and what it might look like. Take note, importantly, this is version 1.1 of the document. It's going to be important to understand that this is going to be adapting throughout the entire development process. This is going to be a continual process of learning, discovery, educating, and it's going to be agile in the sense of continually changing to meet requirements. So today I might be presenting version 1.1 to various stakeholders in the business. And this might actually springboard some ideas. We might actually realize some things that have been proposed here aren't going to fit. This would be a perfect opportunity to start spinning up some more ideas and coming up with the best solution. So jumping right in, we're going to see different views. This is actually largely based on something called the 4+1 logical view of system architecture. The 4 being business view, logic view, process view, development view. Sorry, actually it should be logical view, process view, development view, and physical view. I've added in business view here and non-functional requirements, but the +1 is going to be the use cases. So we'll quickly shoot through these different views, but just understand that these are the viewpoints of different stakeholders involved in the development of the solution. It's going to be really important to actually understand each stakeholder's view of the project, because this will break down the wall of confusion and isolation between different parties and make sure there's a culture of collaboration and sharing in order to produce a successful result in the end. The business view, this is going to be the view of the management and the product owner. This view is going to be where you'd see something like an objective and vision. So how is this product actually impacting the real world? What is the ultimate objective and vision? Funny story, I've been involved in developing a project where the team finished successfully building it. Eventually, in the end of the process, we got a talk from the product owners, and they said to us, "Did you know what you have built today? This project is going to revolutionize communication in the banking industry in South Africa." That was really inspirational, but the funny thing was that the development team did not have that view. To us, this was just a basic CRUD application. We just needed to finish this technical requirement of this CRUD application. So in the end, having this view is going to really inspire the team to ultimately build what we set out to do. You know, teams want to actually impact the real world. We don't want to just be writing code in a dark little room somewhere. We want to be impacting the real world and seeing how the stuff we build affects people's lives. So you might have a business capabilities section. This would be an overview of some of the important different capability that the application needs to perform. Jumping right along, success metrics. Success metrics, what's going to be important is note that each one of these different metrics is actually a measurable thing. So unique visitors, page views, numbers of sales, positive reviews, okay, uptime and availability. I think 9.99999 is a bit unrealistic, but this is just an example, right? So this is talking about what success metrics we need to achieve with the software. But it's not talking about how we're going to achieve it yet, and it's not talking about how we're going to measure it yet. That'll be brought out in different sections of the application. But for now, it's just important to see there are these success metrics which we need to achieve. Okay, we're going to outline various stakeholders. This is an example of some of the important people. like management, operational and development teams, customers, okay, a customer success team. Okay, we're going to go now into the next major section. This is non-functional requirements. Many times we focus on the functional requirements. Okay, the application needs to be able to search product catalog, create an order, check out, create a delivery. But non-functional requirements are also important when building an application. So does it perform well? Okay. Does it handle high volumes of traffic? What's going to be good here is also to realize some of the cost implications of these from the get-go. Like handling really high volumes of traffic is going to mean more roads, right? Like, and roads cost money. So just understand like how much deliverability do you want to have, and just give the stakeholders an understanding of that from the start. Things like portability, reliability. Does it work on different devices? Is the software reliable, not crashing, not failing? Like if YouTube crashed today or Microsoft, would we be able to learn more about a sad document? I don't think so. Okay, availability, security, usability. And a basic little thing I think about is like, is my grandmother going to be able to use this application? Okay, it needs to be usable and accessible. Okay, getting out of breath. Jumping onto the physical view. So this would be more like the operational team, people who are going to be building out the cloud infrastructure, things like servers and databases, things like DNS, API load balancing. This I've built here as an example of how we could deliver like a scalable application. Here you're going to see things like the virtual private cloud, where some of the different servers are located, what kind of, in this case, AWS solutions are we using EKS, we're using DynamoDB, how we're protecting the app. We've put everything in front of a web application firewall to make sure we don't get security issues. This is going to be just like an overview and help the operational team to see some of the things they need to set up. You could zoom into like more of a service and component diagram. This will show like some of the more, like we talked about, EKS clusters. These are some of the actual software Docker images will be running. So we're going to be running like Grafana, Prometheus, Keycloak. There's going to be all the custom built APIs. There's going to be a Redis cluster and these different things. So this is showing how some of these different things are connecting together and some of the different software packages that need to run inside our servers. Okay, jumping into a logical view. Okay, the people who's going to be most interested in this are going to be your developers, your software engineers. We're proposing to use something called clean architecture. Here you're going to get into some of the details of the architecture, how it's supposed to work together in order for your team to build something which will ultimately last for the long run and not just be throwaway, read-only code in the end. We're also going to talk about how we want this to be like a modular web API. This is a good kind of solution in the current climate where companies don't have a lot of extra money to spend. We want to build something that's easy to deploy. We want to build something that's going to work out the box and not have a lot of like dependencies around deployment. Make it easy for the team to build out the solution quickly, but still keep nice clean separation so that these things could be built out into, for example, microservices if the need arises in the future. But for now, we just make it nice and modular. We create a shipments API, a product API, a categories API, payments API, and all these things are self-contained. They cannot reach out of their boundaries and touch different parts. You could have like agile teams working on each of these different sections separately, but all working together in one repo that's been deployed together, just in this example, right? Okay, even zooming in more, you can talk about like the domain aggregate diagrams. We're going to be using something called domain-driven design. You're ready from the get-go, giving your team an idea of some of the important aggregates that we need to maintain in the solution. And it also creates a ubiquitous language. So like everyone from the stakeholders to the operational team to the customer success people have access to this, and they can see some of these important nouns that we're going to be using a lot in the business: shipment, product, category, customer, order, payment. We're not going to be using different words, but we're all going to know what we're talking about. We'll have the same dictionary. And this is just the way to build. So this is, in any case, a domain aggregate diagram. I'm going to jump on. Here we're going to look at the main component diagram. So this is even like a UML diagram of even more details. What are some of the important properties? What are some of the important methods? This is like an object-oriented design. So yeah, from here you can see like important entities: order, shipment, product, customers, payments, and you can then see also some like value type entities like price. That's money. What is money? Money is not an entity because it doesn't have an ID, right? Money is just a thing. It has an amount and a currency. Okay, so this kind of gives the development team a good way to start developing. Next off, we're going to look at the process view. This is also going to be important for developers, but it's also going to be important for people like product managers so that they understand the different flows in the app. This is a quick flow that shows how we can build PCI DSS compliant workflows of customers buying products on the website. That's one of the important requirements for the application. Here's another quick one: the registration and login sequence diagram, showing how we use Keycloak to handle some of the important things like encryption and password management and user identity. Okay, here, this is a quick one of how like the Outbox pattern works. We're going to create like decoupled APIs that can emit certain events in order to react to them in the application in a nice decoupled way. So jumping on, we're going to look at the the development view. This is where you're especially going to be looking at like the development teams. You're going to be looking at the product managers. How do we propose that we ultimately build the solution? So this is just an example of how it could be. We're going to have multiple shorter sprints, looking at some of our important use cases, building them out in sprints, and you're going to be continually deploying on these different days on a schedule. The team knows that they need to cross the finish line. They need to push for these days. So we're making sure we're being productive. So we're bringing sprint one's work into pre-production, kind of in monitoring there, in regression. There's automated tests running, making sure that the work is correct, and then it's deploying out to production on the Wednesday. But that's kind of on a back burner. If we follow this process correctly, like we're not taking in too much work, we're taking in short little small chunks, making sure we're having lots of small deployments so that we release stable code to production. And you're able to also focus on your new sprint work, bring it through, deploy it to quality assurance, monitor that, deploy it through to pre-production, demo the work that you've done, carry on with your next sprint work on the back burner, release the work to production. This creates like a continuous cycle. The demos, you'd have different stakeholders involved, like the product owners seeing what's actually being built and giving continuous feedback so that we have short increments of failure and we like agile in our process. This is a quick picture of what it could look like for our Git flow, like users committing changes to branches, these changes being committed to a development environment that's automatically deployed, quality assurance environment, ultimately to the staging or pre-production environment where there's final regressions. automated tests, manual tests, and ultimately sign off for the work to be moved into production. And staging is going to be super hypercritical to the business to make sure that whatever has been released is perfect before it ever reaches clients. So to the developers, staging is actually like production to them, you know, it's hypercritical. Okay, last but not least, we're going to look at use cases. This is the plus one of the 4+1 architectural views. You can have a look, Google around what is the 4+1 architectural view of planning. But use cases, I find this is a really nice way for development teams to build out the requirements for the application. I find user stories sometimes we get a little bit tired and of just the same kind of, as a user, I would like to repeat it again and again and again. Use cases are just a nice way. You can see the template on the right. You have like a name. What is the use case? In this case, add product to cart. Actor, who is doing this? It's the customer. Basic flow. What are the steps for this to work? Alternative flows. So like, what are different ways for it to work? And then things like the post condition. What's the state of the application after this is done? Sorry, I'm jumping all over, but you also have like preconditions. What's the state of the application to allow this flow to happen? So, example, the customer needs to be logged in, right? Or whatever it could be. This could be like your high level use cases that you base your sprints around, and you deliver these as like chunks of work in small little iterations to make sure that your project is deployed successfully. So yeah, I hope you enjoyed that. That was a quick just shoot through. I got out of breath, but I just in a short way wanted to present important sections of this without taking too much of your time. So yeah, please like skip around to parts of the videos that might be useful to you. As an example, I built this all with a really nice tool called Mural. Just have a look for that. Mural, that's how I made all the diagrams and everything like that for today. Okay, sweet. Hope you have a good one. Cheers for now. Bye. So that was it. Again, I wanted to shoot through for you very quickly, just to give you the entire document in one place. Look at the timestamps below. Please excuse some of my fumbling over my words and kind of running out of breath. I wanted to just do that all for you in one quick shot. And again, this would in real life be much more detailed, covering every single aspect, but I tried to highlight some of the important sections and different parts you might want to include. Typically, this would be for a solutions architect, but it might be something you want to add to your arsenal as even a software engineer or product manager in order to document your entire process of your whatever software you're building much more thoroughly. So that's it for today. I hope you enjoyed. Cheers for now.